All right, ladies and gentlemen. Hopefully I'm learning a lot at this workshop to be able to come back and share with you. Sorry I can't be there today. Here's your video lesson. This is section 3. We learned yesterday how to solve two-step equations, so this is simply an extension of that, which is to translate words and numbers into an equation. And then, depending on the directions, solve it or not. So if the directions tell you to solve it, you're going to. Otherwise, you're just going to write it and leave it alone. So take 1, 2, 3, 4, 5, 3 minutes, 4 minutes, 5 minutes. Your first 5 minutes here. Pause the video. Try these problems on your own. When you're ready to check, come back and do that. Here's number 1. N equals 2. Number 2, n equals 4. Number 3, a equals 1. So a couple different ways to think about this one. If negative a equals negative 1, then positive a has to equal positive 1. So another way to think of it is when you originally do the problem, 3 minus what equals 2? Well, 3 minus 1 equals 2. Hopefully you can do that in your head. The reality here is to get from this step to this step, you could either multiply or divide both sides by negative 1. Technically, this negative a means negative 1 times a, so I should divide both sides by negative 1, and that's how I get positive 1. But don't overthink it. A equals 1. This one might be a little tricky. Number 4 is a equals negative 16. So you have a situation here in which you need to combine like terms. Plus 2a minus 3a. That net total is negative a. It's negative 1, right? 2 minus 3 would be negative 1. So it's negative a. Add 5 to both sides, you get negative a equals 16. So positive a equals negative 16. All right, let's walk you through number 5. Jack traveled 5 miles plus 3 times as many miles as Janice. So normally I would say use J for Janice, the number of miles Janice traveled, because that's what I don't know. He traveled 23 miles in all. How far did Janice travel? So we've got Jack and Janice. I'm going to use C for Jack just because it's J-A-C, and J-A-N for Janice. So C equals Jack's miles, number of Jack's miles, and, Juk, and N equals Janice's miles. So I know Jack's miles. It tells me how many miles he traveled, 23 in all. And it gives me a relationship between the number of miles he traveled and Janice's. So first thing I'm going to say is Jack's miles equals 23. So C equals 23. And that's fine. Jack traveled 5 miles plus 3 times as many miles as Janice. I don't know how many miles Janice traveled, but I know that this 23 miles is going to be set equal to 5 plus 3 times as many miles as Janice. And Janice is what I don't know. Janice is N. That total is 23. And when I solve this, that's going to tell me how many miles Janice traveled. So I'm going to subtract 5 from both sides. That gives me 3n equals 18. And divide both sides by 3. Should give me n equals 6, which means Janice traveled, Janice traveled 6 miles. Equals 6 miles. Alright, so please feel free to go back and review any of those. This kind of magician made things disappear there. Otherwise, let's move on. Essential question. Let me zoom this in, otherwise it's going to look silly. Oh, that's not what I want. That's the shade. There we go. That's good. Aha. Bam, and there you have it. Okay, so today, again, we're looking at equivalence, and specifically for 2-3, we're going to be looking at I can. Sorry about that. It's getting late and I'm tired. I can. Translate sentences into equations. So you're going to be able to take your sentence that is given to you, translate it into an equation, define a variable, and solve and write equations. We kind of introduced that to you in the previous section where you were asked to define, write, and solve. It's pretty much the same goal, except we're going to translate it first. So really, you've already done the second part, so that should be a little bit encouraging in terms of having success with this lesson. Is you've already done the second part of the lesson. Now all we're really worried about is the first part. So when we're translating, we're taking words, just like translating one language into another. We're going to start with words and make an equation out of it. So translate the sentence into an equation. A couple of things about an equation. You know that it's going to be a complete math thought. You know that there is going to be an equal sign there. So the key is to identify the pieces that are going to give you either operations, numerical values, or where the equal sign itself is going to lie. So 8 less than 3 times a number is negative 23. So I read it the first time, I'm kind of looking for numbers. Next time through, I'm going to look for operations. 8 less than 3, 8 less than is going to indicate an operation. 3 times a number is negative 23. Now I'm going to think about where's the variable. Variable is a number, so there's that guy. And then the last thing I'm going to look for is the equal sign. The equal sign, generally speaking, will literally have the word equals or say is. So I see an is right there. There's my equal sign. So right now what I have is 8, the number 8 and an operation, 3 and an operation with a number, a variable, and an equal sign and a negative 23, all in that order. Okay, 8 less than 3 times a number is negative 23. Now, the caveat here is, obviously this means multiplication, this means subtraction, but here's the deal. 8 less than 3 times a number. 8 less than something, for example, 8 less than 10 would be 10 minus 8. 8 less than 9 would be 9 minus 8. 8 less than 13 would be 13 minus 8. So they start us off with a bit of a curveball. I'm actually going to have to flip the order of these around to get it right. The way I like to explain it is this. 8 less than 3 times a number is what it says, which means 8 is less than 3 times a number. So in order to do that properly, I have to subtract 8 from 3 times a number. And that is going to look a little something like this. Doesn't matter, when you define your variable, pick any letter, doesn't matter which one for all intents and purposes right now. I like x's, so I'm going to use x. 3x minus 8 equals negative 23. Now, did it say anything about solving? No, all it said was translate. So as soon as I translate, I'm done. 8 less than 3 times a number. 8 less than 3 times a number. A lot of times it's confusing because you're used to seeing the less than symbol. That's not what it means in this case. Less than is indicating subtraction. Why isn't it 8 minus 3x? Because it says 8 less than 3 times a number. That means that 8 is less than 3 times a number. So generally speaking, here's the bigger value, here's the smaller value. I'm used to subtracting smaller numbers from bigger values. Okay. It's a math vocabulary situation. Is equals negative 23, negative 23. I don't have to solve this. I don't have to solve this. So there's your example for number 1, written as an equation. Next part, translate 3 more than half a number is 15 into an equation. All right, so same thing. Let's break this into pieces. We're going to look for numbers. 3, half, 15. And we're also going to look for operations. 3 more than half a number. Okay, so this is both a number and an operation. If I'm having something, I'm either dividing it by 2 or multiplying it by a half. I wish it would have said of, half of a number, but it might not always say that. Of would indicate multiplying, but that's kind of a number sense thing. You're already familiar with that. So there's my number, my unknown, my variable, and there's my is, which is going to indicate where my equal sign goes. So if I read this again, 3 more than half a number is 15. All right, so let's put the pieces together. 3 more than half a number is 15. Why didn't I flip this around? Well, up here, subtraction, order is important. Commutative property does not apply. Down here, addition, order is not important. Commutative property does apply. So it's certainly correct to have 1 half x plus 3. You could flip these around. That'd be just fine. For all intents and purposes of writing this the way that it is written, though, it's perfectly okay to put that 3 in front. So here's my equation translated from words into numerical and variable terms. All right. Let's move along. Again, translate into a sentence. Now it's going to slightly change the order of things. 13 is 7 more than 1/5 of a number. All right, so there's my of this time. 13, 7, 1/5. Those are my numerical values. Then I've got, my operations. More than, of. Of means multiply. Now I'm looking for my variable. The number. Now I'm looking for my equal sign. Is. So again, for all intents and purposes, more than indicating addition, of indicating multiplication. Is the order of addition important? No, it isn't. So I can just go ahead and write this exactly in the order it appears. 13 is 7 more than 1/5 of a number. 1/5 times n, 1/5 times x, whatever the case may be right there. All right. It's hard to do this on here, but if you're writing the vertical fraction, 1/5, that's obviously fine too. This is just easier for me to type this way. Okay. So we're good there. Translate 19 is 2 more than 5 times a number into an equation. So the only thing that happened between these two is the is whatever is on the right side, and over here the blank is on the left. So same situation, except variables on the left, for example 1, and variables on the right, for example 2, which leads me to believe it's going to be on the right here. So again, let's get our situation out here. I highly doubt that you have 2 highlighters and 2 pens at your disposal. Just do your best to kind of mark this up the right way. So translate 19 is 2 more than 5 times a number. Okay, so there's my numerical values. Here come my operations. More than, times, and then I'm looking for my variable, number, and then I'm looking for my equal sign, is. More than indicates addition, times indicates multiplication. Because I'm adding, order is not important. I can just write this the way that it appears in that order. So here we go. 19 is 2 more than 5 times our number. There we are. 19 equals 2 plus 5x. Could you have 5x plus 2? Absolutely. That's perfectly fine. I'm just writing it that way because it's the way that it was given to me, and the commutative property says that order of addition is not important. Take a minute to get to page 130 in your book. You're going to be responsible for A, B, and C. I'll get there while you're getting there. I had my book open. Hey, look, there it is. Page 130, examples A, B, and C. We'll check back with you shortly. Please pause the video and work. and unpause when you're ready to check. Alright, so with letter A, 15 equals 3 more than 6 times a number. Could you have 3 plus 6n? Yes, you absolutely could. In fact, I would encourage you to write it that way simply because that is the way it is given to you here, and the order of addition is not important. For the next one, same sort of idea. 10 increased by the quotient of a number and 6. So a quotient of a number and 6 looks like that. Number divided by 6 is 5. 10 increased by the quotient of a number and 6 is 5. And then lastly, with letter C, the difference between 12 and 2/3 of a number. So difference means subtraction. 12 and 2/3 of a number are the values that I'm looking for. Order is important, which means 12 came first, I should use that first. 2/3 of a number came second, I should use that second. So it is 12 minus 2/3 n is 18. I don't have to solve any of these, I'm just translating. Okay. If you need to see them again, pause and go back. Otherwise, well, let's forge ahead. Next page. Now we're going to look at some word problems. I believe we're going to define a variable, translate, and potentially solve all of these. Number 3. You buy 3 books that each cost the same amount in a magazine, all for $55.99. Does anybody do that anymore, or we just go like on Amazon or whatever in our Kindle and buy books or whatever to digitally read? You know that the magazine costs $1.99. How much does each book cost? Okay, so let's get our handy dandy highlighting tools out here and see exactly what we're working with. You buy 3 books that each cost the same amount. Okay, so do I know how much a book is? No, in fact, it's asking me in the very last question, how much does each book cost? Okay, so let's use B for book. It's not explicitly telling me to define a variable, but I'm going to go ahead and say that B equals the cost of a book. Okay, B equals cost of 1 book. Now, but wait, Mr. Hanson, it says that you're buying 3 books. Yes, I realize that. So check this out. Here's my total purchase. Ready? 3 books. Book plus book plus book plus a magazine, $1.99, equals $55.99. You with me there? 3 books plus the $1.99 for a magazine. In fact, if I wanted to get really technical here, I could say M equals the cost of a magazine. Now, the deal is, I know how much a magazine is. It gave me that in the problem, right? It gave that to me. So, sorry, still working with these. Okay, so B equals the cost of a book, M equals the cost of a magazine. I know how much the cost of a magazine is. Cost of a magazine is $1.99. So 3 of these plus 1 of those equals $55.99. So here comes my situation over here. Book plus book plus book. In other words, 3 times the cost of 1 book. 3 books, right? 3 times the cost of a book plus $1.99 equals the total of $55.99. That's my equation that I need to solve. Now, where did it say define a variable, write, and solve an equation? Did it say that anywhere? No, it didn't. I'm implying or inferring that's what I have to do. So here's my situation that I need to solve for. What do you see? I see addition and I see multiplication, which means we are going to do the inverse of each of those. First thing I'm going to need to do is subtract $1.99 from each side of the equation. That's going to give me nice compatible numbers to work with. 3b over here, as the 199s have canceled, equals 54. Divide both sides by 3. I can tell you this calculates equally. B equals 18. So the cost of a book is, you guessed it, $18. Alright. If you need to go back and review that one, please do. Otherwise, we're going to move on. Kendra paid $7 for her admission ticket to the fair and bought 12 ride tickets. She spent a total of $31. on admission and ride tickets. Write and solve an equation to find the cost of one ride ticket. So this one's a little more explicit with the instructions, write and solve an equation. So $7 for admission ticket to the fair and bought 12 ride tickets. Okay, and she spent a total of $31. The total is significant. Write and solve an equation to find the cost of one ride ticket. So she bought 12 ride tickets. I don't know how much a ride ticket is. I do know that her admission was $7. So again, kind of keeping in the tradition of what I did up here. My unknown, I'm going to call it either T for ticket or R for ride ticket. Doesn't really matter. Let's say T for ticket. So T equals the cost of a ticket, one ticket. And I also know that A for admission equals 7. Cost of admission, and that was $7. So what am I doing here? I know that she bought 12 tickets, so 12 times T, 12 times the cost of one ticket, plus the $7 for admission equals the $31 total. I'm going to go ahead and write that as an equation. 12T plus 7 equals 31. So there's my right portion. Check that off. And then solve. So I'm going to be solving this for T, and that is going to give me the cost of one ticket. So I see addition. I am going to subtract 7 from both sides. You kind of see where this is going. 12T equals 24. Divide both sides by 12, the coefficient with the variable. And that gives me T equals 2. So one ride ticket costs $2. Alright, hopefully you don't have any questions with that. If you do, again, feel free to rewind and review. Last example, I believe, set of examples. A personal trainer buys a weight bench for $500 and W weights for $24.99 each. The total cost of the purchase is $849.86. How many weights were purchased? Okay, so I know that the weight bench is $500 and W weights for $24.99 each. So now I know the cost of each weight, but I don't know how many weights were bought. So the basic idea here is I have 3 pieces of information to put into my equation, and I am going to solve for one of the missing pieces. So I'm looking at this again in the tradition of what I did up here. It's already telling me that W is now the number of weights. I know the cost, so it's important to differentiate between cost and number of something. So in this case, W is the number of weights. I know the cost, $24.99 each, and I really don't have another variable in there, do I, that I could define. So W equals the number of weights. So the number of weights times $24.99, because it's $24.99 each. Each is generally an indicator of multiplication. I'm going to add to that the price of the bench, and that is going to be the total of $849.86. So it's going to look a little something like this. It doesn't really matter because I'm using addition. If I put the 500 first or the $24.99 first, it's really not going to matter. So because I have some number sense and I like putting my variable first, I'm going to go ahead and write it this way. $24.99 plus 500 equals $849.86. And then I'm going to have to calculate that situation. So I see addition, so that means subtract. Subtract 500 from both sides. Please be sure to line these up correctly with the whole numbers. If you need to put your .00 here to help that, do it. So I'm going to have 86 over there. Looks like 349.86. And I'm going to have my $24.99 on the other side. So $24.99 W equals 349.86. When I divide, I'm dividing both sides by the $24.99. Always the coefficient, the number with the variable. Yes, this is a pain in the butt to do long division. Guess what? We're going to do it anyway. make that a little bit smaller, I guess. That's perfect. Okay. So 349.86 divided by 24.99. Move the decimal twice. Move the decimal twice. It comes up there, just in case. Chances are, so like think about the context of this. I'm talking about the number of weights. It's going to be a whole number. It's not going to be a decimal. So just think about that. I'm putting 24.99 into 3498. That goes in once. Here's where it might get a little bit crazy. So I'm going to subtract 24.99. I have to borrow to make that 18. So this is now an 8. 18 minus 9 is 9. Can't do 8 minus 9. Borrow. That's now a 3. That's an 18. 18 minus 9 is 9. Can't do the 3 minus 4. Borrow. That becomes a 2. This is a 13. 13 minus 9. Bring down a 6. And reload. All right, I'll own up to what I did. I checked it on the calculator just to be sure. So if I was going to take a guess, remember I take a guess, 24.99 to get to there. It's going to be at least 3 times. Probably, if I wasn't sure, the lead digit here 2 times 5 is 10, right? So 5 is going to be too high. So if I guess 4, 24.99 times 4. Let's see what happens. 9 times 4 is 36. 9 times 4 is 36 plus 3 is 39. 4 times 4 is 16 plus 3 is 9. I like where this is going. 2 times 4 is 8 plus 1 is 9. Congratulations. We hit that right on the head. I'm not going to write that again. So 14 weights. How many weights were purchased? 14 weights. Cursive there for you. Not bad, huh? 14 weights. W-E-I-G-H-T-S. All right. Go ahead and review that one if you need to. Otherwise, move on ahead. I guess you can see that. Membership at the health club is $15 per month plus $10 for each exercise class taken. Jill paid $75 for the month of September. Write and solve an equation to find the number of exercise classes Jill took in September. Okay, so this is a little bit tricky because you see per month, but then you also see only 1 month of September. So this part right here, the $15 per month, under normal circumstances, this would be 15 times the number of months, but we're only talking about 1 month, the month of September. So the reality is this is the fee, the flat fee or flat rate for that 1 month, which means 15 is being added to something. It's $15 that month no matter what. Then $10 for each class taken. So plus 10 times the number of classes, in this case, which would be C. And then that total amount is $75 just for the month of September. We're not even talking about the whole year. So just to recap that, I'm looking for the number of classes, right? Write and solve an equation to find the number of exercise classes Jill took in September. So I'm looking for the number of classes. That is represented by the letter C right now, number of classes. 10 times the number of classes plus the $15 for the month equals 75. Okay? So I'm going to subtract subtract 15 away from both sides. That gives me 10C equals 60. Divide both sides by 10. That gives me C equals 6, so it's 6 classes. 6 classes. All right. There is a word problem example for you to try on page 131. If we turn to the page over here, it should be on this side. Where did it go? Oh, I know what happened. I flipped too many pages. Let's see over here. There we are. So there it is at the bottom. Current temperature is 54 degrees. It is expected to rise 2.5 degrees Fahrenheit each hour. And how many hours would the temperature be 84 degrees? Okay. So go ahead and try that one. 2.5 degrees each hour sounds like the variable hour. You can use h if you want to. Check back when you're done. Alright, so you should have 12 hours. Something like 2.5h plus 54 equals 84. Subtract 54 from both sides. You get 30. And 30 divided by 2.5 should give you the 12. Alright. Sweet. So here's what I would suggest. I'm going to pause this, and I'm going to, well, here, let's go to the next page. Here's what we're going to do, because I want you to have some time in class to work. You have an option of doing your homework or IXL after the guided practice page. You're going to kind of kick this around on your own. You really only have to do 1 through 4. So take a few minutes and do 1 through 4. Just want to make sure that you can handle this on your own before moving on without me, because I'm not there, remember. Take 4 or 5 minutes and knock this out. Come back and check the answers when you're done, and then you can move on. Alright, so here's what you have. And now don't feel like you have to have exactly what is here. If you have some variation of it, it is fine. Let me explain. 1 more than 3 times a number is 7. So if you had 1 plus 3n equals 7, you're fine. In other words, these two things were flipped around. That's fine. 7 less than 1/4 of a number is -1. This order cannot be changed. This has to be 1/4 n minus 7 equals -1. The quotient of a number in 5 less 10. Okay, so subtract 10 from that. It's not a really common way to see that, but that is indeed what it means, is subtract 10, is 3. So n over 5, or n divided by 5, minus 10 equals 3. This one got a little crazy on you, huh? With the directions, define a variable, so whatever letter you used should have represented the daily find. Write and solve. So we've got 4.32 plus 4 times whatever your variable was equals 6.48 for $6.48. You could have these two terms flipped around. 4 times letter plus 4.32. That's perfectly fine. And the daily fine is 54 cents. In other words, $0.54. That represents 54 cents. All right. So the rest of the time is yours to work. I believe that we have, oh no, we have more. Look at that. Awesome. I love it. It's great stuff. One more example. And then you can move on. I apologize for that. At least you got a head start on your guided practice. These are actually going to be more or less making sure you read the problem correctly than anything else. So well, let's take a look. Your and your friend's lunch cost $19. Okay, so combined. Your lunch cost $3 more than your friend's. How much was your friend's lunch? So I don't know how much either lunch costs. I do know that together they were $19, and yours is $3 more than your friend's. How much is your friend's lunch? Okay, so the thing about defining a variable here is if I want to find your friend's lunch, then that's exactly what I'm going to do. I'm going to set my variable to be cost of friend's lunch, so that when I find my variable, I'm done. This is cost of friend's lunch. All right, so what is the relationship between your friend's lunch and your lunch? It says your lunch is $3 more. So in order for it to be equal, okay, in order for it to be equal, I would have to add 3 to the friend's. Agree so far? Okay, so friend's lunch is what the friend's lunch costs, plus the friend's lunch plus 3, which represents the cost of your lunch, because your lunch is $3 more than your friend's. That total is $19. So let me just kind of backtrack there. Your lunch, or I'm sorry, your friend's lunch costs F dollars. Your lunch is $3 more than that, which would be F plus 3. There is that represented amount right there. The combination of those two is $19 total. Okay, so really the parentheses don't need to be there. I'm just showing you that the parentheses represent this one quantity, which is your lunch. So from here, I'm going to combine like terms. F plus F is 2F plus 3 equals 19. And I'm going to go ahead and solve this two-step equation from there. Subtract 3 from both sides. I'm running out of room, sorry. That's going to give me 2F equals 16. Divide both sides by 2. And that gives me F equals 8. Okay, so F represents what? The cost of a friend's lunch. Is that what I want? Yes, it is. So friend's lunch costs $8. How much does your lunch cost? Well, $3 more. 8 plus 3 is 11. So your lunch costs $11. Your friend's costs 8. Is 8 plus 11 19? Yes, it is. Ta-da! Congratulations. So we're going to apply the same sort of idea to the next example. Let me erase this so that I actually have room to write in the spot where I should be writing. Last problem. Oops. Oh, that's not what I meant to do. There we go. Sorry. It's getting late. It's after 11. It's been a long day. Anyhow, you and your friend spent a total of $33 for dinner. Okay, great. Your dinner cost $5 less than your friend's. Write and solve an equation to find how much you spent for dinner. So last time it was your friend, this time it's you. So pick a letter, doesn't matter. D for dinner, great. D is going to be your dinner, my dinner. It's the cost. So the two things happening here are your dinner and your friends. Right now I'm trying to find your dinner. You and your friends spent a total of $33 for dinner. Your dinner costs $5 less than your friends. Okay, so that means friends was $5 more. The two together equals 33. So again, I'm going to use this D as a reference point. D is your dinner plus friend's dinner, which was $5 more, right, than mine. So compared to my dinner is $5 less than my friend's. You could also say my friend's is $5 more. So my dinner minus 5 equals 33. Correction, plus 5. Because this value right here is my friend, which was your dinner plus 5. My dinner plus 5, because my dinner is $5 less. So my dinner plus 5 is his. Combine like terms. D plus D is 2D. I'll be able to tell at the end if I made a mistake. That's the great part. Subtract 5 from both sides. 2D equals 28. Divide both sides by 2. And I get D equals 14, which means my dinner cost $14. My dinner was less expensive, correct? It's $5 less than my friend's. So if I add $5 to this, I get 19, right? And 14 and 19 is 33. So did I do it right? Yes, I did. My dinner cost $14. Okay, now you're prepared. Option 1, homework page 133. It's due anyways. You can do it now, or you can do it later, or you can work on W2, your choice. Have a great day. See you tomorrow.